we are very thankful to the GIZ for funding this project, and we have been doing this study since 2010. In 2010, we started with development of the conceptual framework, and then we got additional funding for doing the implementation of the conceptual framework that we developed. Now, this is the first place we are doing a presentation about the final results that we are getting from this sort of a 4-year project, and where else than GIZ, from ZEF, where we have been collaborating very closely on doing this study. And we have this project is coming to an end toward the end of this year. And our biggest plan is to publish a book. We are already signing a contract with the Springer, in which we'll report all the results. And we are actually going to, the book will be called The Economics of Land Degradation and Improvement. There is an I which we have added for a very strong reason, because the results we are seeing, it is not all about land degradation. There is also improvement, an aspect which is very, very important. There are people who are calling this economics of sustainable land management, which they are on the positive side. They are leaving out the land degradation. Now, for us, historically, we have been talking about ELD. We have added an I because, as you'll see, there is a lot of improvement that is happening. Now, today, what we are doing, we are going to be reporting the land degradation. The land degradation aspect, which is very important. How we are computing it is something which is very simple, but at the same time is very complicated. And it is giving us an insight of land degradation that we have not seen before. It has not been reported in literature. And we are going to share today what we got. And I just expect you to give me one gift. Criticize very much what we are doing so that we can improve it. We're also making a video. We showed it at the Global Soil Week. We had that video. We are going to have it, and there's even more things that we are currently doing. As I said, there are a lot of new things. The first thing was actually to use and to improve the NDVI. The NDVI is a measure of greenness that the FAO and other bodies that are doing the land degradation have been using. We have corrected for that because there is carbon fertilization and issues related to rainfall variability that also affects NDVI. We have corrected for that, and we are about to publish a discussion paper very soon. And this one was led by Bao. Bao was a student of ZEF, so this is ZEF product, and it is really going very strong. And we are using the total economic value of land to assess how it has changed over time. The Millennium Ecosystem Services report of 2005 defines land degradation as loss of ecosystem services over long term. And there's a very big, huge change and very big difference between the traditional assessment of economics of land degradation if you are not looking at all the value of ecosystems that are lost or they are gained. And the results, as you see, and you have seen in the short brief, they are astoundingly different from what we have been using before. To assess the land degradation, we are looking at the change of land use. Land use change can lead to improvement of ecosystem services, or it can lead to degradation or loss of ecosystem services, depending on what is changed, replacing what. If a forest is cut and crops are planted, there is a loss of ecosystem services because the value of the forest is much higher than the value of the other, of the crops. So that's just like an example. Thank you. In addition, we are going to look at land that did not change. There was no land use change. The same cropland was in 2000, and the same land is today used as cropland. So there is still land degradation there. As you see, the land degradation is happening a lot in agricultural land, and majority of the studies in the past have actually focused very much on the cropland and livestock, and they are not looking very much into the cropland, the land use change, and that's something that we are looking today. In addition to that, we're also doing focus group discussion because the MODIS data is based on satellites and all that, but the satellites cannot see what's happening on the ground. They can only tell us that a forest change to cropland, but what are the farmers feeling, or how are the communities feeling? That one is something that we have to go speak with the local people for us to know what is actually done, what is actually happening. We are very fortunate. We have interns who are working with us. They are funded again with the GIZ, which is very good news, because interns always work harder than everybody else. And we have them. They are going to these several countries, and they are within this audience right now as we speak. Now, because I have a lot of things to do, to show you, I may confuse you on the way. So I want to get started with conclusions. So if you get confused over the way, you must have got the message that we want to pass. So based only on land use change and land cover change, the total cost of land degradation is about 2.2 trillion US dollars. This is about 4% of the global GDP of about 57 trillion. This is a very big loss. And Sub-Saharan Africa accounts for the largest loss in the world. Europe, where I'm actually standing on right now, has the minimum loss of ecosystem services. So congratulations to Europe. You are doing better than the rest of the world. And one other thing which is interesting is that the hotspots of loss of the cost of land degradation, they are both in developed countries and in developing countries. It's not only the story that, oh, it's in Africa where the land degradation is happening. No, no, no. We are going to see hotspots in developed countries. Now, this is the big difference, that we are seeing that 62% of the loss of ecosystem services is actually incurred by the global community or the national level community. The people who are taking care of the land, the ones that are getting direct cost of land degradation, that direct cost of land degradation to farmers, to land users, is only 38%. So it's the world that is actually bearing the brunt of land degradation. And the people, the local people, they are just bearing about 38% of that land degradation. So this land degradation is a global problem. It is not a local problem. And I'm going to show you and justify all that. Now, let's now get started. You can fall asleep because we have got the main message and the conclusion of the study itself. This is not the first study that has done the cost of land degradation. There was one which was done by FAO about 2007. They estimated the total cost is only 40 billion US dollars per year. Look at what we are saying, 2.2 trillion. There's a very huge, big difference. And another one which was done last year, UNCCD, they report about 490 billion US dollars. Again, look at what we are seeing. What's the difference? Why are our numbers so big and so dramatically different from the rest? It's because we are using the total economic value that is according to the definition of land degradation used by the Millennium Ecosystem Assessment. That's the biggest reason that we can explain that big difference. What approach are we using? It's a very simple approach. It's a total economic value approach. And in this one, we use what we call in economics the value transfer approach, that you do case studies in selected areas, and then, but you have to select those case study areas in a way which is going to allow you to extrapolate the results to areas which are relevant. And the team, we are very lucky with Mark Shower is in here. He was the secretary of the team. They did a lot of studies all around the world. In total, there were 300 case studies around the world to do the total economic value. And we use those values to be able to transfer the value to the other areas where such study was not done. And this has allowed us to attach values to all the biomes that we are using in this case to be able to know the value of land degradation or improvement in every area, depending on the case studies that were done and where we applied those values that we got from the TIB website that has very good data, which we used a lot. Now, as we say that land use change can be a land degradation or it can be an improvement depending on what is replacing what. But at the same time, we do have other forms of land degradation, which there was no land use change, but there was land degrading management practices used, and those ones can also lead to land degradation. For those ones, we are using a global level simulation, crop simulation and also livestock simulation models. Evelyn is here, is one of the other students who is with us. She's doing the livestock model or global model to be able to determine the land degradation that comes from degrading grazing lands. And then I'm going to receive the results today about the global level simulation analysis showing the land degraded areas and the yield over time, how it's changed, so that we can be able to get the value of the cost of land degradation in areas that have been using land degrading management practices. So the way it works is that I'm sorry, this is, I'm trying to do, no, I'm not going to trust it anyway. But anyway, what we're doing, the cost of land degradation, CLD, is given by the change of land use. And the change of land use, you are changing from forest to crops. Maybe forest is the TEV1, total economic value 1, minus the value that you gain because you have planted crops. If you plant crops, so you are replacing the value that you were getting from the forest by a smaller value. So that difference is where there is a change, the change in value of the ecosystem services. So there is a big value that you are taking away, and you replace it with a smaller value, which is the TV2, the cropland value that you get from that. And that difference is what we see as the cost of land degradation. If it is negative, it means that there was an improvement. But if it is positive, it means that there was land degradation. So that simple formula is what we used. And then for the non-land use, we are using the simulation models. And this one, over time, you see if there was declining of yield, land productivity, then you just multiply by the total economic value that you have. The data that we are using for the land use change degradation, we are using the MODIS data, which is the moderate zero resolution imaging spectroradiometer. This data is from 2001 to 2010. This data is very good, much better than the NDVI because it's ground truth. They have been ground truth, and the resolution is very good, 1 kilometer, which is much better than the NDVI, which is about 8 kilometers. And the biggest thing is that it is ground truth, so it's a forest, it's a forest. It's not something else. And that thing gives us a very good confidence to see the dynamics of land use change over time in the area that we're looking at, that we are sure of what we are seeing. And that's something which helped us very much to be able to determine the TEV. And then the prices of crops, we use the provisioning services. This was from FAO. And then the TIB data set that we had, as I said, there were about 300 case studies. And then for the land degradation of land that did not experience land use change, we are doing the crop simulation and also the trade-off analysis that Evelyn is doing with the colleagues. And then the forest and woodlands, we did not have data, and we are just making an assumption that if MODIS is telling us there was a forest in 2001 and a forest in 2010, we assume that it did not degrade itself. It remains with its value as it was in the past. So we are making that assumption, and economists are very famous in making a lot of assumptions, and they have two hands all the time. And why MODIS, I have explained that. And then now these are the results that we get from the TIB study. Forest is the most, it has the highest value of all the biomes that we have on land. its value is the largest. But if you look at the oceans, then the oceans, they have much larger value, but we are dealing with land. We are not looking at the ocean. So it has the largest value. It's about 5,000 US dollars per year per hectare. That's a very big, large value. But the tropical forests actually are more valuable than the biomes in the temperature countries. And the grassland is followed, and then the woodlands. I did not put the crops because they vary very, very, very widely. Just imagine you have 1 hectare in northern Tanzania and that same hectare in Kansas where I did my degree. The difference between those two are too big. I didn't want to give you a confusing number here. So they are very big. Managed ecosystem services, they vary a lot. And I'm not putting them here, but we have them in our analysis. So what's the per capita GDP? We know this story. We know which countries are rich and which are poor. But the story changes when you look at the total economic value of the biomes that we're looking at, which is forest, grassland, woodlands, and all that. And this is the story. That, well, we see that Northern America still is very rich, but Brazil is also very rich, and we can see DRC Congo in Africa is the middle-income countries. But when you look at the GDP, DRC is the 2nd or the 4th poorest country in the world. Now, this study, it tells us a wrong story. Why? Even though Congo is endowed with very rich ecosystem services, but the benefits that are accruing from the forest in Congo, they are not internalized in the country only. About 60% of that is because of the carbon sequestration, which Congo, yes, there is carbon sequestration happening, but that's the benefit of the world and is not Congo. So even though this one tells us the local location of those benefits, but those benefits are accrued and the benefits are drawn by the world and not where the forest is. So it is a map which is showing the location of the value, but the people who are benefiting from that value are not located in the area where that value is. And that's where my conclusion was saying that, well, land degradation is 60% of the value is lost by the world and not the local people where those biomes are located. And so this map, I'm just showing it, but it's a very wrong map. It should not tell you that DRC Congo is very rich. We know it's poor because they cannot internalize the benefits of the biomes that they have locally. Now, this is the costs of land degradation, and we are looking at that we are comparing with the GDP, the traditional methods that we use, and then what I want to draw your attention are some aspects. Look at Sub-Saharan Africa. The cost of land degradation is about 526 billion US dollars. As percent of the total loss of ecosystem services, Sub-Saharan Africa accounts for about 17% of that. But if you look at that loss, again, in a very myopic way, you are assuming that the benefits, the total economic value of the biomes in Africa are internalized within the region, then we can say that the cost of land degradation as percent of the GDP is about 60%. Again, you can see one thing which is very clear in this case, that because the region of Africa is very much dependent on natural resources, its value, its economic value, is very much determined by the natural resources. And as such, we see that as percent of the GDP, it accounts for about 60%. But again, I keep repeating the same thing, that we are not internalizing the benefits, and we are also not internalizing the cost of land degradation within Africa. So I'm giving you this just to tell you the importance of looking at the global level when we are doing the land degradation aspects, given that the benefits of improvement are not internalized in an area where we are, just part of it is internalized and the other part is not, and also that the costs of land degradation, they are not only located in an area where the land degradation is happening. And we are seeing Europe here, it has the lowest value, only 0.4, and that's something which is telling you that where this area, there is quite an improvement. Now this is the map. Where is the severity of land degradation located? Now look at the hotspots. Look at the darkest areas. The northern Russia, and then Alaska, and the very northern Canada. And of course, we have seen the Amazon, the degradation that's happening. So all what we are saying is that the cost of land degradation is allocated both in high-income countries and in low-income countries. Now, let's compare this with what Bauer has done in this study that we are talking about, which corrects for carbon fertilization and also for the rainfall variability. We see more or less the same pattern. We are seeing that there is the same severe loss of NDVI in northern Canada and then in Alaska and then in this area. And we are also seeing the same thing here. And this area, again, I can just bring back so you can follow what is going on. And this one here. So who bears the heaviest burden of the cost of land degradation? The answer is obvious, the world. 62% of the cost of land degradation, either it goes to the world or off-site, off the farm, where that kind of land degradation is happening. Now, that was the global look. We picked a few countries to look at the case studies and just put into perspective the aspects. And I'm going to talk about Bhutan. I saw a name which sounded like Bhutanese. Is there a Bhutanese in this country? Because I want him or her to be very proud. He didn't come. But anyway, so we'll talk good things about Bhutan, and there's no Bhutanese. We are taking Bhutan because it's one of the case study countries. And they have very interesting thing that can put into context the thing that we are looking at the global level. So we did this study, and we looked at the opportunities in Bhutan. That first of all, the first thing that one would know is that the mountains and those very steep slopes, those are actually opportunities for generation of hydroelectric power. 22% of the GDP of the country is accounted for by hydroelectric power, but there is a lot of soil erosion which puts a lot of sediment loading into those hydroelectric power plants in such a way that the country spends about quite a big percentage of its GDP to take care of that problem. Now, the good thing about Bhutan is that they have very strong cultural values related to the environment. And I think you know that the Mahayana Buddhism, this one is coexistent with nature, is very eco-friendly. And 25% of the population lives in protected areas. And that tells you that if they are living in protected areas, they are very eco-friendly. Otherwise, they would have cleared the whole forest, but they have not. And that tells you that those cultural values, they are actually very good, and they should be exploited. One thing which was very shocking is that there was a lot of land which has been abandoned by the people, and the reason behind that abandonment, 34% of them were saying that because of wildlife. In my country, in other countries, the wildlife will be killed. Humans will not run away from wildlife. It happens in Bhutan, telling you that those eco-friendly cultural values are very important for achieving the sustainable land management. Now, because Alicia is already wasting some time, I would like to go straight to the problem that the country is facing. The first thing is that there was a policy in 1961 to 1980 for harvesting the Himalayas, just the same thing that we see in the Amazon. They wanted to conquer the Amazon, which was a jungle. In Bhutan, they also wanted to have this, more or less the same policy. of harvesting the forest. It happened, but it killed the local values that was very much preserving the environment. And there was a lot of land degradation, forest degradation. As such, the country is currently using about $16 million to just take into account the sediment loading. That is, it increased significantly during those times. And also there's a lot of construction, and that construction, road construction, is leading to a very severe land degradation. Like, look at this river. It's well loaded with a lot of sediment because of the construction that's happening, as you can see here. This is leading to the type of land degradation that we see. Now, if you look at, there is also low productivity, there is low adoption rate and low productivity of those management practices, and the low adoption rate of manure, inorganic fertilizer, improved seed, and private forest. Now, this is something which is very interesting. We are seeing what we are calling unholy cross. Unholy cross is the situation where we are looking at the returns of profitability of different land management practices. One would expect as an economist that, well, the more profitable land management is, the higher the adoption rate. But we are seeing the opposite, and that's why the trend lines showing the profitability of land management and its adoption rate, they are going in the more opposite direction, forming what we are calling the unholy cross. This was the case in Bhutan, and I'm going to also show you another case in several countries in Africa, the same exact thing. The message is the most profitable land management practices are the ones which are more sustainable, but the adoption rate is low. Why? And those kind of things. For Bhutan, we saw that tenure security was very important for them to adopt manure, urea, and all that. And also owning livestock was very important. Access to roads and also extension services were all very important aspects that we actually, because of the lower access to roads and also extension agents, those were leading to low adoption, even when such management practices are most profitable and also very sustainable. These showing the access to extension services and also roads. As you can see, about 30% of the population is living away more than 3 hours away from the road, and that's something which is very serious. So we did a SWOT model to look at the sediment loading with sustainable land management and without, and we saw that it can be reduced by about 50% if there is sustainable forest management, and also for agriculture it will reduce by 23%. And these are the sediment loading with and without SLM in Bhutan. Now the message that we wanted to say is that if farmers upstream are managing sustainably their forest, they get only, it's about only 40% of the benefit accrues to them. The other 60% accrues downstream in the hydraulic power generation plants. So there should be some methods of compensating the people upstream so that they can do this sustainable land management, because they cannot internalize the benefits of managing forests sustainably so that they can reduce the sediment loading that we are seeing. And what can be done? The country is already doing this payment for ecosystem services, but it's doing it in the wrong way. The hydroelectric power generation, they are giving that money to the government, and the government provide extension services to the people to tell them, oh, plant trees. They have no connection between the hydroelectric power plants and the farmers who are implementing that. And our recommendation was that they should be giving that money direct to the farmers instead of passing it through the government. Now, let me go to Sub-Saharan Africa. First of all, just a reminder that Sub-Saharan Africa is accounting for about 17% of the cost of land degradation that we have seen, but it accounts for about 24% of the total economic value. We asked the farmers in Nigeria, simple question: are you aware of provisioning services in your area? They know it very well, about 100% of them. Regulating services, including the climate regulation, only 8% of the communities we interviewed, they had an idea that there was a benefit of their forest doing carbon sequestration, but 92% of the communities had no idea about carbon sequestration. So if you are investing and you are prodding the farmers to, okay, keep your forest because it is doing carbon regulation, you are just not talking the language that anybody can understand. Meaning that if people don't know, they are not going to invest to increase the benefit that the world is looking at. But now if you look at the climate mitigation and all that, they are talking of mitigation, a language which the farmers are not understanding, and that's why we do not see much response to such the climate change issues that we talk about. And the cultural services, this one is quite interesting, that the spiritual values, 59% of the people know about the spiritual values of the forest and other ecosystem services that are happening in the area. So they are very much aware of this. That's good news to us, and we have to take that into account. I would have given you a story in Uganda where the government sold a forest called Mabira Forest, and the communities around that forest said, oh, no, don't cut that forest to plant biofuel sugarcane because our spirits live in that forest. If you cut it, they are going to be angry, will not have rainfall, and that's not a good news. Now, the scientists will tell you the same exact story that the farmers were saying, but the languages that the scientists are using and the farmers are using is different. They're talking of spirits, but we are talking about the ecosystem services that we derive from the forest, that it catches rainfall and all those things. Now, there are language of the people, spirits, language of the scientists, ecosystem services. They're talking about the same thing. One is calling it a big spoon, another one is calling it a spade, but same exact thing. The government didn't know. They thought, oh, we are creating jobs, we have to cut the forest and plant sugarcane. They didn't have no idea about the ecosystem services, the spirit, the cultural values that the people we are obtaining. Now, we did a comparison of the value that a farmer who is by the forest, they are trying to debate on whether to cut the forest and plant maize or to keep the forest. And we just took the value, the provisioning values that the farmers obtained from that forest, and the decision was that the forest should be cut to plant maize, because these are the tangible benefits that the people get from the timber, from the forest, and this is the maize. So the maize value, they obtain about $600 per hectare, but if they just take the forest itself without the timber, you get only 90. So the solution is cut the forest and plant maize. Now, these are the results I'm showing what has been changing in Africa, which has been accounting for 23% of the loss. There has been a lot of forest loss because they are planting the crops that we have seen here. The solution of this guy, cut the trees and plant maize. And this is what we are seeing. Those are the countries that have changed their land use type for a long time. So I have run out of my time, but the only thing which I wanted to show, the unholy cross again in Africa. It is obtained from Kenya, Malawi, Nigeria, Tanzania, those countries. The same thing that we saw in Bhutan. And one of the reasons is that we asked the extension agents in Nigeria, what messages do you give to your farmers? Improved seeds, 60% of them. Inorganic fertilizer, 18% of them. Agrochemicals, 10% of them. Planting spacing, 10% of them. Organic fertilizer, only 1% are telling people about organic inputs as the important things. There's nothing about climate change. There's nothing about other things that are very important. Ecosystem services, meaning that the farmers are not educated about some of the important aspects that we want them to know. Now, I think I should end up here because the conclusion I gave them in the beginning. So, Alicia, I'm going to shut up and listen to the people. Thank you very much.
So now the floor is open for comments and questions. If you have any comments or questions, please welcome. Please ask Ephraim. So we collect 3 comments, and then we let Ephraim answer. Please, first Marlene, Tobias, and then Nicholas.
My question is not related to the modeling. It's related to one of the maps you showed earlier on, the GDP map of the world, pinkish map. And I noticed that on this map, France is very poor, and I was wondering about that. That's all right. One more, I think. Yeah.
Okay.
Yeah.
Ah,
France is 0 to 1,000.
yeah.
And that's really standing out.
Okay.
Same as Norway.
Yeah,
Same we were?
is in
Norway.
Norway too?
Yes.
Okay. Huh. Well, this is the data that we are generating, and it's based on the MODIS data. But this is something which is, I don't know why, but that's something which is quite striking. Yeah, but we'll have
The
to.
wrong comma at the wrong place.
Oh no, I think the data was the geospatial. We imposed all this into that, but I think it is something that we just have to look at it. Yeah, so France is and Norway as well. Okay. Yeah, okay, we'll look into that. Well, I don't have an answer to that, but that's something which is striking.
Can I also ask something
Yeah.
about your modeling?
You okay?
That is the TEV for forest.
Mm-hmm.
You mentioned is much higher than it is for crops.
Mm-hmm.
And I was wondering, because for the farmers, at least in the short run, you also showed it at one of the graphs later on, that
Mm-hmm.
the value of the cropland is much higher than the forest land. So the TEV, I'm not sure how this is calculated.
We didn't show the cropland, but again, that one depends very much. It was surprising in Samoa because we calculated the value of the cropland at country level, and even in the country, different values for different areas. And the place which was very shocking was actually Samoa. They grow horticultural crops, and the value per hectare is $32,000, which was very, very high. But in general, the majority of the crops that occupy the largest area in the world, which is rice, maize, and wheat, and the value is quite low, much lower than even the woodlands. Yeah. Yes?
Yes, but how do you calculate the TEV? I wondered how can you derive that value?
Those values were calculated by TIB. TIB had 300 case studies that we transfer that value. We use those values depending on where they are applicable. They have such values, and there is a database, the TIB database, which is called Ecosystem Services Valuation Database, ESDV. Alicia has that website where you can see those values. There were 3,000 different values that were derived from that, but we used that database. We didn't create it ourselves.
Okay, Ephraim, let us collect those. Tobias, Nicholas, and Jamal.
My question pointed in the same direction, that your conclusions, they hinge mainly on the results or on the data of those 300 case studies. And I would have liked to give more transparency of how you actually arrived at these figures. I would have liked to see a little more detail of what was done in these 300 case studies. Also, how comparable are these studies? Was it calculated in a methodologically consistent way?
Okay.
We all know that contingent valuation studies, they often lead to very inflated values, and all these issues around the valuation and comparability. I would have liked to have highlighted it.
There is a good.
Nicholas.
Thanks for the presentation. I think it's nice to see that valuation of land degradation is sort of going away from agricultural lands and production change values, etc., and going to the global picture. But my question is, can you give us an idea about how much of these results are driven by one specific ecosystem service, which is carbon sequestration. It seems that all the areas that are highlighted in dark in your maps there are the ones where you have a lot of forests, and I assume that the main value that is attached to the forest ecosystem is carbon sequestration. Yeah? And then, sort of similar to what we heard before, it would be nice to have some sort of trade-off between these long-term benefits and the more short-term benefits of cropping systems or pastureland.
Thank you a lot, Ephraim, for your presentation. I think this was you gave us an introduction. You just gave an overview of what you did in your research. It's very difficult to go to the details, but it's very interesting. So I would have a lot of questions, but I wouldn't know what to do. So do you have the results of this research published already? So gone through the peer review and published, so that other organizations could also refer and cite your figures and outlines. So this is the first question. And the second, you were talking about the internalizing, the problem of internalizing of ecosystem services. So what do you mean exactly by this? And how can the government of one country internalize the total value of its ecosystem services of different types of ecosystems? If you have just an example, practical example.
Okay. Very good. Now, beginning with Tobias's question, how were these values computed and all that, there is a very good publication by De Groot and Costanza. It was published last year, and they are using, they actually sort of reviewed all the literature and then put all this into context. And it didn't put it, the citation is below there. It's, if I do escape here, you'll be able to see this one, this study, De Groot. This is the one which is showing a lot of things that if you read it, it's publicly available. And you can ask Alicia, he can give you the website, the link to the TIB database that we used, and where, how each one of them was used. There are many methods that were used. And in this review of De Groot and Costanza, they are giving very good values and all the reviews. And I think it's from this that you can be able to see the method that we used, which value we used, but it's all according to the literature that we use. But at the same time, in the case study countries, we are going to develop our own ecosystem value. And the students that we are studying with, they are the ones who are doing Marlin and Clemens. Clemens is going to Tanzania. He's going to do the total economic valuation of the biomes in the case study countries. And Marlin is going to Ethiopia. And we have another student, again, funded by GIZ. She's now in Senegal. She's doing the same thing. So we are going to compare the result that we get from the valuation at the local level and these case study countries, and then be able to say something about how accurate, how different they are from the global study that we have seen. One thing I can say is that we are not having like the best estimates, but we do have, and we are using what is best and what is available currently in literature. And we are just based on the literature review, but in our methods paper that we are using, we identified areas where we can take the values and where we can transfer those values to other areas where there was no case study. So the method of value transfer that I talked about in the beginning is the one which you start from the case studies. You select sentinel sites where you have to have a case study for you to transfer the value to other areas which are relevant and they are comparable where the case study was done. And that's the method that we used. But again, I keep saying that we did not develop these values. We drew them from the TIB website, that is the database, which is publicly available. Nicholas, yes, the forest has the largest total economic value by virtue of its value, because the biodiversity, the forests account for the largest number of biodiversity value and a lot of other things. That's the most valuable land-based biome, and that's the one which is, of course, automatically is the one which is driving a lot of value that we do have. Meaning that the deforestation problem that we currently have, especially in Africa, is a global liability that needs to be taken into account. We are losing a lot of value because of the changes that I just showed for the few countries, the many countries that are changing a lot. I wanted to show you that. For example, we can see that countries like Benin, it increased its cropland by about 80%. And 75% of the land, cropland expansion, it replaces forests. That's a very big problem. Yes, our values are driven by the biome that has the largest value. But that's the nature of the total economic value that we are measuring in this case. And the results tend to be very different from the other studies that are not looking at the total economic value. Jamal, this is an initial analysis. We are going to have a review. Our methods paper was reviewed thoroughly, the one that we used to implement this study. It was reviewed thoroughly, and in the Springer book that we are going to be publishing, we are going to have even further review. So in short, we have not published these results, but we are now presenting for the first time, and we're receiving very strong review right here. We are going to improve on that, and by the end of the year, when the Springer book is going to be published, our results will be thoroughly reviewed. But we already have some of the chapters have already been reviewed thoroughly, and we are very willing to share with you the ones that have been reviewed already and the ones that are already undergoing review. But this work, the one that I present today, has not been reviewed yet. But the method that we used has been reviewed. Internalizing. The internalizing aspect is something which is an important one. In economics, I'll internalize the benefit that is off-site. For example, if I keep a forest, okay, and then it is doing carbon sequestration, that value is accrued by the global community. If the global community can give me money, which is payment for ecosystem services, to incentivize me to keep the forest intact instead of cutting it and planting crops, then I will internalize the benefits. And in the other way, there's Alicia was talking about the polluter pays. In developed countries, you tell the people who are polluting the river to pay for that pollution. They're internalizing the off-site costs of their actions that are taking place by polluting those waters. So that's the process of internalization. It calls for payment for ecosystem services.
We make the second round. Since you have already asked, we start with Tina, then Girma, and then Tobias.
Yeah, thanks for the very nice presentation. But I refer to, I think I missed, over which time frames do you talk? Do you talk like the costs of land degradation over the past 10 years, or here's it between then 73 and 2007, or do you extrapolate for the eternal future? So, which, yeah, what is your time frame you relate this figure to?
Okay. For the total.
Take the second question.
Okay.
Thank you for the presentation. It was interesting to see the global level land degradation, bringing it up to the higher level. I think it may be useful to think of collaboration among countries around the world this problem. My question relates to extension service. You mentioned about the contents of extension service, in which you say that the extension agent is not teaching the people about the importance of this ecosystem services, even if it's not the same term as ecosystem services. They will tell you how existence of the forest helps soil to have a very much more carbon in it, or more fertile soil there, and how forests are useful for springs, and also they think that forests also attract rain, for example. I'm from Ethiopia and I know this from that background. And if we think of teaching people about ecosystem services, instead of thinking of changing their holistic life system, for example, if we think of diversifying livelihood instead of dependence on the forest, that may improve already a lot, rather than teaching them about ecosystem services. So I feel that it is much more than teaching people about the value of the forest. So exchanging service, which has failed already previously, because the traditional approach whereby you think universities and research centers are source of knowledge and technologies, and people are recipients, which has failed already, and we have now a two-way flow of knowledge and technologies. So my comment is, rather than strengthening again about teaching, we should think of other aspects, like, for example, population management and diversifying ecosystem services, livelihood options, and also access to education, other social services.
Yes, I think in these global assessments it's very important to also take different utilities into account. I can probably do with $100 less biodiversity services, but $100 less food production for somebody in Africa may cost his life. So I think difference in utility and also difference in payment, ability to pay is very important, because if the ability to pay drives the value of the valuation studies, then biodiversity and carbon may be very high, and the ability to pay in people in other countries is much lower, and therefore there's less value in the overall assessment. So my question is, to what extent have you already considered these differences? And I think it does make sense to disaggregate these total economic values also, like Nicolas said, into their different services, because you may add them all up, but biodiversity services can be something very different to food production.
Let me start with Tavia's question, because I think it has ramifications of what was also asked by Bettina and Gima. In this TIB database, actually, if you read their reports, they are raising a very important question that, well, is cheaper for us to pay the people in Congo, for example, they were using Madagascar to preserve a forest, than try to pay the people in Munich to preserve the same forest area, because the value attached to the forest in Munich is very, very different from the value that the people in Madagascar can attach that value to. For example, the cultural services, that's something which I'm coming to. The cultural services that is attached in Europe and the cultural service that is attached to a hectare in Madagascar, the values are really, really different. You'll be surprised. So, in short, the values are very different. There is no single value. There are 300 case studies that they did, and in each one of them, they obtained very different figures. And in our analysis, in the transfer value approach that we used different values of cultural services, regulating services, habitat services, cultural services. They were obtaining different values. But my presentation did not want me. I didn't want to have crowded with a lot of values, but we do have values for each of the provisioning services. All elements of the provisioning services, they are different across the globe because of the areas that we selected as sentinel sites from where we can extrapolate those results. Ngima's question about extension services. Well, I fully agree with you that the farmers know the value of ecosystem services. I gave an example of Uganda, cultural services. But the way they use cultural services, our Our spirits live in that forest. If you cut it, they are going to be angry, and they are not going to have rainfall. Spirits. But when a European goes to Uganda to see Mabira Forest, they are going to do tourism, and they are going to be, Joachim von Braun loves very much to watch birds. He's going to be watching those birds and all that. To the local community around them, yeah, there are birds there, but they attach a very different value. Joachim von Braun attaches a very different value. So the beauty is to the eyes of the beholder. And there are different values attached to cultural services, as I answered to Tobias. But at the same time, there are ecosystem services that have no value, or sort of people don't have utility of. For example, carbon sequestration. If you tell the farmers in Mabira Forest in Uganda, don't cut this forest because it's sequestering carbon, they have no idea what you're talking about. But there are local benefits like windbreak and all those things. They know those values. And in this one that we were showing, for example, pollination, you see, 10% of the communities, they were aware about pollination, erosion regulation, they were aware of them, but the awareness is not as high as it is for the provisioning services. All I'm trying to say is that there should be education to the farmers about the ecosystem services that are provided in the area, because some of the management practices, they may be doing them without knowing the impact of what they are doing. For example, using on some of the chemicals that to use the pollinators, they kill the pollinators. Those things, they need some education for them to be aware of the local benefits that derive from the ecosystem services.
My point is, what does this education help the people to preserve the forest while there is a livelihood drive behind to use the forest? Because the forest is less valuable to them than maize crop, for example, in a specific area. So they want to change the forest, natural forest cover, to maize plantation, because it's very useful for their livelihood. So if we teach them only, what difference can we make?
That's where I was, my conclusion at the very beginning is that the land degradation aspect is a global problem. The incidence of the land degradation actually is borne by the global community. Because if the benefits is not tangible and local, the people are not going to attach any value to preserve a forest. They are going to cut it and plant maize, as I showed with this guy, masculine guy, who was cutting the tree. Is exactly what I'm saying, that, well, if we don't pay him to keep that forest, he's going to cut it down and plant maize. Because the tangible local benefits are the ones that drive what they plan and what they do. Did I get all it? Did I miss?
Time dimension.
Time dimension, yeah. For the total economic value, it was between 2001 to 2010. 10 years. But the example that you are looking at as I was talking, I just gave this one as an example, the cropland change between 1997 to 2007. But this is not, it was just showing what has changed in Africa, where there has been a lot of replacement of forests with crops. But this is not time frame. The time frame is between 2001 to 2010. No, each year. Those are annual. We took the average of those 10 years. Yeah.
We do the last round if there are questions. Okay. One question. Do we have more questions then? Okay, the last two questions from Hannes and Jamal.
Hi. I was just wondering, I mean, you framed your speech with the announcement of the book, which is called ELDI, and especially the I, which brings to implementation of the results and to encounter all these things. I was just wondering, how directly could you transfer your insights on the actual costs of land degradation into proactive policy recommendations? I mean, you identify drivers, but if you think about payment for uses and services or other things, the figure of costs actually, I wonder if they can really directly be transferred to the benefits or to direct policy actions in the field.
Yes, Jamal.
Different type of question. On one of your map, you were showing the hotspots for land degradation, and
that the darkest wars the hottest. And how would you explain that in terms of the land degradation, the hotspots were in the northern part, Siberia and Alaska? If I correctly understood that.
Okay.
And it was another country.
This one? Okay. Beginning with Hans' question about the policy implications. Yeah, there is an eye, but these results that I presented is just about land use change and land cover change. There is no land improvement that we are going to do next, and that's something which is also going to be very interesting. And we also did not do analysis. We are still doing those numbers. We're crunching those numbers for the area where there was no land use change. The cropland remained a cropland between 2001 and 2010. We are going to have those numbers, and the cost of land degradation is going to go higher and not lower. And for the land improvement, our initial objective was to look at what's the cost of action and what's the cost of inaction. Now, we are seeing the cost of inaction. The world is losing $2.2 trillion US dollars every year because of land degradation that we have seen happening. But there is good news. There is land improvement as well. Now, the question is, why are we seeing some places improving and some places where there is land degradation? Good example, a good success story is Niger. Niger, it implemented a law where they gave the people the tree tenure, that if you protect a tree or plant a tree, it belongs to you, you can do anything you want with it. And then we saw what we have been calling the regreening of the Sahel. Even when you take away the impact of rainfall variability, like Bao did in this study, there was residual regreening that was attributed to those programs where there was very aggressive programs that were encouraging farmers to plant trees. The country did not invest anything, did not give any money to the people, but they incentivized them. They gave them an incentive of benefiting from protecting of those trees. And it happened. So we do have a series of case studies. I have already presented the Bhutan one, and we are going to present the one for Niger, which shows that what can be done for us to see land improvement and not land degradation that we see. We have to internalize the benefits and penalize the people who are polluting the downstream, and also at the same time, we need to have some other aspects that are going to give an incentive to the people to manage. To do land management. That they are going to be leading to sustainable land management. Jamal's question: why are we seeing hotspots in northern Canada and Alaska? Now, these are the bare facts. One of the reasons is that actually fires. Australia has been suffering a lot of fires a lot of times, and even the same thing goes to northern Canada and Alaska, and also in the Sub-Saharan region. The fires are the ones which are actually leading to this land degradation in the northern hemisphere, mainly. So the fires are also part of the story here.
Thank you very much for coming and for your very insightful comments and suggestions. And thank you very much, Ephraim, for your presentation. These were, as Ephraim said, initial results, and from that perspective, the comments we received and suggestions are very appreciated. Thank you very much.